We are starting now, and here we were discussing about the syllabus, right? Our today's topic is topic,
Sir, Umar called me. Wait.
yeah. Tell him to unmute. Tell him to unmute. Yeah. You can see the screen, Saad. Hello, Saad.
Yes, sir. I can see the screen.
Okay, what you are seeing in the screen?
Sir, energy sources and transfer of energy sources and transfer of energy, sir.
Okay, today's topic we are going to discuss, right?
Yes.
And on this, I gave you class notes. Those class
Yes, sir.
notes cover all these learning outcomes. You see, in class, we discussed different forms of energy with examples in which each form occurs, right? You can remember that I gave you different kinds of energy, like kinetic energy. A student is running, right? Hello.
Yes, sir.
So gravitational potential energy, a book is kept on the table. This way, I gave you lots of examples, right?
Yes, sir.
Okay, then next one is state, the principle of conservation of energy. This one is also given. What is the principle of conservation of energy? Anyone can tell me? From you, anyone can tell me?
What, sir?
Uh,
Principle?
Principle of conservation of energy. If
Oh,
you
sir.
if you
Sir,
can't
sir,
remember, then you can check your classwork copy. That's
Sir,
what
sir,
I
I
told
can
you to
tell, sir.
revise. Yeah, tell me.
Sir,
Hello, Nubrat.
sir, no, sir, no
Hello,
energy
Nubrat.
is,
Yeah, tell me. Yeah, please.
sir, no energy is created or destroyed. It just changes the form.
Okay. That means the total amount of energy in the universe is
Is conserved.
conserved or fixed or constant.
Yeah.
We
Yes, sir.
cannot create or destroy. We
Destroy.
just can convert, right?
Yes, sir.
From
Convert the
one
form.
form to another form. And afterwards, I gave you this one, the formula, right? Formula of
Yes.
kinetic energy, and we also did numericals. Then formula of gravitational potential energy, we also did numericals. In your classwork copy, if you see, you can get it. Then we discussed renewable and non-renewable energy sources, right? Renewable and
Non-renewable.
energy. So you know what is called renewable, what is called non-renewable. Renewable means we can reuse it after using once, that can be used again, right? And it's unlimited.
Yes.
And mostly they don't have any pollutions. I also gave you some,
Notes.
yeah, some, harmful, which one is harmful or what are the advantages of what, right? This way, advantages and disadvantages I gave you in your classwork. Please check out. Huh? These all are required for your exams. Then we have here describe the process by which energy is converted from one form to another, including reference to chemical, fuel energy, hydroelectric generation, solar energy, nuclear energy, geothermal energy, wind energy. So these are the things that how we are getting them and how we are using them. A little bit we need to discuss. That's why we discussed in class. and some of the things came in our worksheet, like geothermal energy. I did not give you any explanation in class, but about geothermal we have diagrams and some more discussions in worksheets. Nuclear energy, we have fission and fusion. We know it. It is in the nucleus. Uh, you have the notes. Look here. Explain nuclear fusion and fission in terms of energy releasing process. Both these we discussed with equations, right, in your class?
Yes,
Hello?
sir.
If you respond, then I understand you are listening to me.
Yes, sir.
Okay. Then describe the process of electricity generation and draw a block diagram of the process from fuel input to electricity output. So this block diagram also we showed in class, that from the beginning, like we gave the example of thermal power stations, right? How
Yes, sir.
electricity is generated in our country mostly, that example we gave, that in the first step we have what? The form of energy is in chemical energy, right?
Chemical or nuclear form, sir.
Yeah, chemical or nuclear form. Then we
Then,
are
sir,
getting next
thermal energy, sir.
thermal energy. By burning it, we are getting thermal energy. Then what you are
Then,
getting?
sir, kinetic energy, sir.
Yes, then
Then, sir, electrical energy, sir.
electrical energy. Awesome. So this way, I gave you a very simple diagram. In the same way, uh, there are a little bit difference in other power station, like in geothermal power station we are directly getting thermal energy, so there is no chemical energy part, right? Clear to you now? Hello?
Yes, sir.
Yeah, geothermal energy, under the ground we get thermal energy directly, so from there we are getting the other steps. So the last part almost similar in all the power stations. Okay, first part, second part, there are some differences. Like hydroelectric energy, we don't have even thermal energy. We have directly kinetic energy, right? From
Yes, sir.
gravitational potential energy, we are getting kinetic energy. Then after that, those steps are similar.
Yeah.
This way we are relating. Now, afterwards, we have work. Work equals force into distance moved. Nubrat is there, right? Nubrat? Hello, Nubrat. Are you there, Nubrat? Now look, we have the formula work equals force into distance moved. In your class, I brought one student and I told him to press the wall, right? That try you can press the wall or not. So that time I found, and we also all saw that the wall was not moved, right? Hello, students.
Yes, sir.
So here we are applying force, but no distance moved. That's why no work done. If there is distance moved, only we can get the work done. Otherwise, we cannot say there is work done. You are
Oh,
giving
okay,
lots
sir.
of force, but there is no distance moved. There is no work done. Afterwards, we had this formula, efficiency. Efficiency, this formula is used, or this idea is used for mainly for getting better output from different engines or machines. Like in car engine, we are using the fuel, right? Hello.
Yes, sir.
Yes, sir.
That form is chemical energy, right? The fuel
Yes, sir.
is in chemical energy form. So, for example, in the chemical energy form, we are getting 1000 joules, for example. And our target, what is our target? Our target is to get the kinetic energy of the car, right? So if the output of the kinetic energy is 500 joules, then we can say it is our useful output energy, right?
Yes, sir.
So 500 joule divided by 1000 joule, our ratio comes 0.5. And if we multiply by 100, then it comes 50%. That means our engine's efficiency is 50%. Clear? Everyone? Hello?
Yes, sir.
Yes,
Shimanto,
sir. Yes, sir. Yes, sir. Yes, sir.
Shimanto, welcome to our class. You
Yes, sir.
joined late. Try to join early.
Sorry, sir.
I'm also recording this class, so they who join late and they who are missing class, don't worry, you will get the recording in your Google Classroom. Okay, my
Okay.
dear,
Okay.
all of you. So efficiency, is it clear to you, everyone? Hello? Hello?
Yes, sir. Yes.
Okay, so the formula of efficiency you have in your classwork copy. We did some numericals in worksheet. Please go through them, then you can understand better. And what is the target of this efficiency? The target of this efficiency is that we can understand how much efficient our engine is or machine is. And we can research on this, that how can we improve the efficiency of the engine and make it more better. Like one example I gave, we are getting the output as 500 joules kinetic energy. If we can make it 700 joules as the output, that's more efficient, right?
Yes, sir.
Okay, this way, this formula helps us to get more output, more better output. Now, discuss the efficiency of energy conversions in common use, particularly those giving electrical output. These examples are discussed in our worksheet. You have MCQ and structured part, there we discussed all this. Now, uh, discuss the usefulness of energy output from a number of energy conversion. This is also related to, you know, this efficiency. Okay, like how much we are getting the output. Already we discussed all these things, that what is the usefulness of the energy output. Those things already came. Define power and recall and use the formula of power. For this one, I gave example in class, like if I give two students of our class the same, assignment or same task, like uh, I'm saying two students to take two boxes of same weight to carry from
Yes, sir.
downstairs to your classroom. So
Yes, sir.
they both are going, same distance, right? From downstairs to your classroom, the vertical height, that is the distance moved, and work done, we can calculate. What is the formula of work done? Force into distance moved,
What's in the
right?
distance?
So weight the weight students, both of them are taking the same amount. That's why their work done is
Let's
same,
say.
but one student is taking more time, another student is taking less time. That time, which student will have more power?
Sir, the student who has take less time, sir.
Less time. Excellent. So this way we calculate the power,
Yes, sir.
because time is inversely proportional here. The student who is taking more time, then his power is less. who is taking less time, his power is
Yeah.
more. It's very simple, and the unit
More.
of power is watt. We can say joule per second or watt, because work done is calculated in joules. So that's all about the class notes. We gave these class notes in class, and I told you many times, and again I'm saying that we are covering all the learning outcomes of Cambridge. Okay, your syllabus. That is the way you will take prepared for Cambridge exams. Okay, in this syllabus, the learning outcomes are giving the same way the question papers will be made. Nothing will come from this outside of these learning outcomes. That's why I always do this, that I cover all the learning outcomes while I'm taking or making the lectures. Got it, everyone? Hello?
Yes, sir.
And your textbook, there is sometimes happening like you are getting some extra information other than this learning outcomes. It also happens that you don't have some of the learning outcomes covered in your textbook. That's why I am giving you the notes, class notes. Are you clear about that?
Yes, sir.
Everyone, now what you are seeing?
So we are.
You
It's
are
a
seeing
worksheet, I
the,
guess.
yeah, you are seeing the worksheet 8, the worksheet I made on this topic. Clear to you? Hello?
Sir,
Hello, sir. Yeah.
এটা কি স্যার এটা কি নরমাল ওয়ার্কশিটের মতো স্যার আমাদের?
This worksheet is also given to class. I gave you the worksheet in class, and we discussed all these questions in class.
I
Sir,
think I
not
was
with
absent.
everybody, sir.
I think I
I
was absent.
Sir, not
I
with everybody, sir.
I think they who
Only me,
were
sir.
absent,
Sir.
they did not get, but most of the students should get it. If you don't get, then for you, I already uploaded. Uh, I already uploaded it in your Google Classroom. Please check. Okay, they who did not get the worksheet, please check there. It's there. 2 days back.
Sir,
Yeah, 2 days back, I uploaded this worksheet.
sir, can you discuss the efficiency part again?
Efficiency part. Okay,
Yes, sir.
no problem. I'm discussing it again. Efficiency, from this word, you understand that it's saying that how much energy or how much work is used for our output. Clear? This is the main thing
Yes, sir.
about efficiency, that how much output we are getting. We are giving lots of input, but the outcome is coming less. Then our engine or machine is less efficient, right?
Yes, sir.
Clear? So the formula
Yes,
is
sir.
energy converted to the required form. That means what we expect or what we want. We want light, or we want kinetic energy, or we want electrical energy. That's
Or the
our required form.
output energy by input energy.
Yeah, input means total input energy, right?
Yes, sir.
Total input energy. So here we are getting energy converted to the required form divided by total energy input for an energy conversion. Now
Yes,
it's
sir.
clear to you?
Yes, sir.
Okay, now we can go to worksheet. Hello?
Yes, sir. We can
Yes,
go
sir.
to the worksheet.
Okay.
Yes, sir. We can.
Okay, now look. Here we have the first question. I'm making it smaller so that everyone can see it all together. Look, this question. Anyone can read this question. Shimanto, you can read
Which one, sir?
this
which one,
one, the question you are seeing on the screen from the.
So we
Sir,
are
we
not.
can't see.
So we
Sir,
can
we
see
are not seeing any question. It is on the same page.
Yes, sir. Same page, sir.
Okay, okay. I am showing you, no problem. If you can't see, then tell me. Otherwise, it is problem that when the recording will go, the students who are absent, they will not understand anything. Now you can see.
Yes, sir.
Yes, sir.
Okay. So Shimanto, you read.
The diagram represents a geothermal power station. তারপর সেটা diagram দেয়া আছে তারপর বলছে which useful energy transformation is taking place.
Okay, very good. Look, geothermal, that means thermal energy underground. Geo means ground, thermal means heat energy, right? So uh, the energy we are getting underground, or the thermal energy we are getting underground, that is called geothermal energy, and it is renewable energy, right? Isn't it?
Yes, sir.
And you know that some parts of the earth is still hot, right? So underground
Yes, sir.
there is lots of thermal energy available, and it is the place, you can see the cursor, right? It is the place the energy is
Yes, sir.
stored, and we are passing cold water uh, in one side of this thermal energy, and the other side
Yeah.
we are this cold water becomes warm, hot,
Warm,
and
boiling,
it's become
reaches the
so
boiling
hot
point.
that it's becoming steam, right? And with the motor we are taking out this steam, right?
Steam. Yes, sir.
Yeah. uh, Here you see hot water will be staying here, but the steam will go up, right? Automatically, right? Hello, are you
Yes, sir.
listening to me?
Yes, sir.
Steam
Yes,
is
sir. Yes, sir.
steam is gas, right? Vapor. If you increase the temperature more and more, then steam will get more kinetic energy, right? As this
Yes, sir.
temperature is very high, as this temperature is very high, are you seeing
No, sir.
now?
No,
Now
Yes,
you
sir.
sir.
can,
Oh, yes,
okay.
sir. Yes, sir.
Now you can see. Okay, good. So this steam will go up with high kinetic energy, and they will turn the turbine, right? So I told you about the block diagram, that parts of the block diagram is similar to this one. Like we are getting thermal energy over here, then we are getting kinetic energy, then it's turning the turbines, and finally we are getting the electrical energy. Clear to you? Hello.
Yes,
Yes,
sir.
sir.
Yes, sir.
So our primary energy, or the first energy we get, that is thermal energy,
Thermal energy.
and the final energy we are getting, that is electrical
Electrical
energy.
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 That's why they are asking you which useful energy transformation is taking place. We will choose option D.
Yes, sir.
Clear to everyone?
Yeah.
Okay, excellent. Now we will go to next question. The next one is question 2. So can anyone read it and explain how to do it?
An astronaut on the moon drops a toolbox of mass 3 kg. It falls from rest and its kinetic energy as it hits the surface is 0.96 joule. At which speed does the toolbox hit the surface of the moon?
Okay, so how you will do it? How
Sir,
you
by
will?
using the kinetic formula, sir. Kinetic energy formula, sir.
Okay, good, very good. What is the formula?
Sir, EK kinetic energy is equals half mv square.
Half mv square. So you will keep the formula that way, or you will rearrange the
No,
formula?
sir, we have to rearrange, sir.
How you will rearrange?
Sir, the kinetic energy is given and the mass is given, so we need to find the velocity here. So the formula is root 2 ek by mass.
Okay, so what is the answer coming?
Sir, 0.8, sir.
0.8. What about others? You understood this? What about others?
Yes, sir. I understood, sir.
There are some more students like Kazi is there,
No,
Nugrat
sir.
is
Kazi
there.
is not.
Kazi
No,
is
Only
sir.
not
me
there.
and Saad is there.
Sir, only two
You
students.
you only present. What about others? They left. Omar was
Yes,
No,
also there.
sir.
sir. I think, sir.
Yes, sir.
They left.
He left.
Okay. So if they are not attending class, but they are complaining, we did not understand, we don't know, then what can we do? Now, the next
Yes.
question. 3, question 3. How can we do it? Who will explain? Hello?
Yes, sir.
Yes, sir.
Yeah,
But by
anyone?
using the power and efficiency formula.
Okay, can
Yes, sir.
you explain step by step how we are doing this?
Sir,
Sir,
first we need to rearrange the formula of the power to find the time. Then after to find the time, yes, sir. Then the power, then the power out is 20 watt, and it is written that it is 25% efficient. So the power that is useful, the useful power is 5 watt. So
Okay,
then we are
tell
going to
me,
divide
tell me first we use the efficiency formula or we'll use the power formula? Which
the
one
power
we'll do
formula,
first?
sir. Power formula.
We are going to find the time, right?
Yes, sir.
So we are getting the power, right? First,
Yes, sir.
how we are getting the power? How much power we are getting?
Sir, 20 watt.
20 watt is given, right? The power of the
Yes,
motor
sir.
is given 20 watt and the system is
but the
20,
efficiency.
So the power is
25%
five.
efficient.
Yes, sir. It means
So
it is 5 watt.
Yes,
so
sir.
it
5 watt.
becomes 5 watt. So our power is actually now 5 watt, isn't it?
Yes, sir.
Yes, sir.
Okay, now what we have more? We have here, what is this? This one is
Sir,
weight.
Wait, sir.
yes, sir.
Weight means force, right? And this one, what
This
is
one is the
this?
height, sir.
This
Sir,
one is the
height, sir.
height. Height means
The
distance
distance.
moved.
Distance,
Yes,
sir.
sir.
So force
Distance.
into distance moved, you will get the work
Work
done.
done.
And you have
Yes,
the
sir.
formula power equals work done by time,
Yes, sir.
isn't it?
Yes, sir.
So you can use that formula to find the time by rearranging the formula. And what is your answer coming for time?
Sir, 4 seconds, sir.
Sir, 0.4 seconds.
No, 4 seconds, I think.
Still confused?
No, sir. 4 seconds, sir. Confirm, sir.
Sir, 4 seconds. Yes, sir. 4 seconds.
4 seconds. Okay. Or you can say 4.0 seconds, not 0.4, right?
Yes, sir. Four. Was it 4.0?
Okay,
Sir,
now
sir, I still have a problem, sir.
what problem?
Sir, first we are using the power formula, right?
Yes. Power means
Sir,
we are getting the power from the efficiency, right? The power is
yes, sir. Not from the time. Yeah. There
yeah.
is a problem, sir.
So
We are not
that
getting it from the time.
from the time, okay. You have the formula power equals work done by time, right?
Yes, sir.
So time will be work done by power.
Yes, sir.
Now you are clear?
Time will be work.
Work done
No,
by,
sir. No, sir. We are getting the power by multiplying, sir. 20 watt into 25%.
yeah,
There
that
is a
power we are getting from the efficiency, you know, this one is 25% efficient. That means how much power is their output,
yes, sir.
useful
Yes, sir.
output. That one we are finding 5 watt. Clear now?
Oh yeah, yes sir. Yes.
25% of 20 watt, it is 5 watt.
Yes sir.
Clear now?
Yes sir.
Okay. So now it's clear. We can go to next question.
Yes sir.
Okay. Now question 4. Saad, you read and explain.
Yes sir. So question for a car travels a distance of 200 meter in 20 seconds. The engine of the car provides a driving force of 1000 N. What is the power output of the engine?
Yeah. So you are getting here distance, time, then
And
force.
force.
Now you can find the power. What is
Sir,
the
I
formula?
think, sir, the formula, sir, P equals to F into D by time.
Yes. So your F is
Power,
1000.
power output.
Yeah. Your
Power. F
your
is
F is
1000,
1000. D
distance
is
is 200,
200. Yeah.
and time is 20 seconds.
Then what is the answer comes?
Sir,
Sir,
10,000 watt.
10,000 watts, sir.
10,000 watt. Excellent. Now 5. This question a bit tricky, right? Question
Yes,
number
sir.
5. It was a bit tricky. Now Shivanto, can you explain this question?
Sir, here they told us to find the work done. So the formula of work done is F multiplied by D. But sir, I haven't understand when, uh, why we multiplied 0.80 instead
Excellent.
of
So, sir,
Excellent.
sir,
This
can I
this
tell, sir?
Yeah, this note I gave you in class. If you couldn't write that time, now you write, please. Shimanto,
Sir, sir, can
Sad is telling you. Sad is telling you, telling us. Now you write, please. Yeah.
Shivanto, first mark that the the barrel is against the gravity. Work done on the barrel
okay,
against the gravity. Mark that part.
okay.
Okay.
Yes,
Mark
sir.
that part. That means if we are finding the work done against gravity, then we have
Yes,
to
That
sir.
calculate the
height,
straight height
Height, sir. It will
the
be
or
straight height.
vertical
against
height.
gravity. Okay.
Vertical height. Also, you should mention this one there. They who did not write, you should mention it. We have to consider vertical height. Clear?
Okay, sir.
Yes, sir.
Now, can you tell me the working? How you got the working and what is the answer?
Sir,
Sir,
1,600 joule. And B,
1000,
sir, B. And 600 joule,
sir,
B.
600 joules.
1600 joules.
Yes, sir.
Clear? Any
Yes.
problems here?
No, sir.
No, sir.
No. So we can go to next question. Next question is
So next
uh,
question is very easy, sir. No problem.
it's very easy. Only you have to do working for all of them. You have
Yes,
to
sir.
do working and check. You can find it. What is the answer of it?
Sir,
Six.
D.
Sir, huh?
D, sir. D.
What is the answer?
Sir,
D,
D,
sir.
sir.
D. D.
D. Question number
Yes,
6,
sir.
right? Yeah, the answer is D. So it's clear to you. Then we have only 1 minute now. We have to finish the class. Thank you so much for joining. Tomorrow we have class again, right,
Yes, sir.
everyone? So here we are finishing question number 6 from question 7. We'll continue tomorrow. Okay.
Okay, sir.
Allah Hafiz. See you tomorrow.
Okay, sir. Assalamu alaikum, sir.
Wa alaikum salam wa rahmatullahi wa barakatuh.